Hello there and welcome to Weekend's Web App. This is day 17 and today we're going to be working through internationalizing numbers. If you're following along at home and you've already pulled the repo down, you can get where we're starting from by using git checkout day 16 because that's where we finished on the last stream. Git checkout day 16 and that'll get you started right where we are. As per usual, going to get the server started up. And then we're going to pretty much launch into our work. So if I jump over here, I'll just close this out. If I jump over here and open up localhost 8080, you'll see where we sort of finished. We ended up having translations as a concept, and then also localizing of all of our how shall we say this? Localizing all of our dates here. And just to expand a little bit further, we added a time here, although we haven't actually got the time on the data. So instead, we just sort of output it just so that we could see how this is all going to work. And we went a little bit further than what we actually need right now. So if I just pop this out of the way, what am I doing here? What am I doing? If I jump on over to our localize right now, we've got a series of formatters for dates, for date times, and then finally format date time UTC. And this is one that can actually get localized in terms of a time zone thing. So you can see here, we've got abbreviation locale, full local, abbreviation UTC, and full UTC. Now, this is interesting because I reckon what we'd usually do is actually tack the word UTC onto the end of these ones. But I'll wait till we actually start to use that before we really sort of investigate that sort of thing. I'm sort of happy with where our date time localization ended up. What we're going to be leaping into now is the localization of numbers, and I anticipate this not taking too long. But instead of using a library like numeral.js, and like this is a really important thing that we covered right near the tail end of our last stream, is that these dependencies are not free, okay? And this is only the tip of the iceberg. We will eventually need more dependencies, and all of them come at a cost of size and all that sort of like. It comes across a size in terms of execution speed, in terms of complexity potentially. Every dependency you bring in is not a guarantee that that gets you out of having to do any of the work yourself. You still have to do the work, right? And that's part of the ethos behind me using a platform layer, is because I want to have control over that sort of stuff. I want to be able to say, all right, do I really need to have this dependency? Do I really need to use this type of code, right? And writing with a platform layer in mind, even if that platform literally just calls a library, still gives me options, right? Because even in this case here, where I am using Luxon, what if I decided not to? Well, that would mean that everywhere where I do formatting of dates, I only have one place where I need to overcome that need. It would be different if I'm using Luxon for modifying date times and all that sort of thing, and it's in our main application code base. But everything that's in the platform layer is sort of easier to change just by definition, right? And that's why I'm sort of comfortable with saying, all right, well, let's see if we can do formatting of numbers within the context of this. And really to leap into this, we're just going to go into the INTL framework, or rather INTL object for the internationalization API. And as I said, so it provides language-sensitive string comparison, which is nice, number formatting, and date and time formatting. So that language-sensitive string comparison is probably something that will end up in our platform layer eventually, just so that we're not doing the sort directly in the code like we currently are. But what we're really talking about today is we're talking about the numeric formatting. So we're going to take a look at that API and see what we can do with it. So you can see here we've got this concept of formatting. So it creates a format, and potentially we could cache these sorts of things. And then once you create that formatting sort of object, then you run the format function on it, and it takes the number, turns it into makes it look how it needs to. And it looks like it's going to do some good work for us. It's going to do stuff like put the currency on the correct side, whether it's front or back, and potentially it's going to work with our comma separating and like the way commas work or the way decimals work, which is different in some countries, right? And all of that should hopefully mean that we can sort of just call into this and get a few of the different types of styles of numeric formatting that we need. So in order to test this, we're just going to put a couple of number formats into our app, as usual, write usage code first. And we'll think about how we'd want to use this sort of thing. So where are we? Homepage? Yes, we are. Good stuff. All right, so let's think of how we're going to do this number. I mean, realistically, we've got two kinds of things here. We've got numbers and we've got currency. Currency has got its own sort of internationalization thing. But most of the time then you've got numbers, and I guess potentially numbers behave differently depending on what units they're attached to, or meters squared or something like that. But maybe let's ignore the unit conversions and all that sort of stuff and just think about formatting numbers and currency specifically, and just leave the rest by the wayside for the moment. Do we want a different function for formatting numbers versus formatting currency? I feel like we do. Just because formatting numbers is a little bit different than formatting currency, because currency is one of those ones where you have to conform to the user's expectation if you want to be legit about it. Because formatting currency incorrectly can be a way to mislead your users, whereas formatting a number incorrectly might weird them out, but should still potentially be fine by them, really. So I think that's what we'll do. We'll have a format number and we'll have a format currency. So we'll pull both of them out, and obviously they're going to be type errors until we get things working as we want to. But for the moment, what we're going to do is going to jump down here and we'll work with this. Now, there is an interesting thing that we will eventually have to overcome, but I'll just leave that as a surprise, and just that'll pad out this stream a bit, because this might be a really short stream, really. We'll see how we go. All right, let's put in some numbers here. So first of all, let's just do a standard format number, and we'll put a bunch of numbers in there, and we'll just do that. We'll just call it that, and then that's it. And we'll format a currency, and we'll assume that with the currency we always have to supply the what it's a currency of. So let's just experiment with AUD to start off with, and we'll have a bit of a play with that and see how that comes out. Now, if we jump into the localized index, we need to first of all deal with the format number and format currency not being there. So I'm just going to break this up. And then down here we'll have ourselves, oopsie daisy, we'll deal with number translation. More like number formatting. Let's do that. That's better. Okay. So we have ourselves a format number, and we know that we're at very least going to have to accept a number and then return something that's sort of like that, but we'll just return num.toString to start off with, and we'll get more sophisticated with that afterwards. All right, next up, got format currency. Just nudge this. Hey, oops, never mind. Okay. So Okay, we'll do the same with this one just for now, and then we'll slowly bring in our API to deal with it. All right, currency type, currency code. That's the currency code there, and we need to bind them as well. As I said, we'll eventually do a shorthand, which means we won't have to split the definition and the binding like we are currently. But for now, we'll just grin and bear it because I don't want to distract from what we're actually trying to do here. All right. So format currency is the other method. So we're going to bind that as well. And now, at the very least, our code should work. Won't be great, but it will work. And we'll jump home, and you can see our numbers right here, right here. And they're just being output as strings, so no sort of formatting is going on with them. All right, good. So just looking at these examples, I'm going to start off with currency first. So currency, it looks like we would have to create a new international. So let's just do new intl dot number format, and then it's going to be this dot lang code, and then potentially we just do no. Oh no, we got to do currency. So we'll say that the style is currency, and the currency is currency code. It's getting a bit long, so I'm gonna break the line instead, like this. So we do that, and then we format against it. What's that other one? Just the resolved options. Okay, never mind that. Okay, and we're gonna format the number. All right, let's see how that goes. Looking good. We've got some dollars here. That's using AUD, and you can see it's got the decimal there as well. Maybe we cannot make that optional, but we'll see how that goes. All right, let's just try something like what is it? Japanese yen is JPY. That's the current currency code. It's interesting. I guess in this language code, it does it like that. Let's see if I use JAJP or the language code for Japan, whether it displays it differently. So it does. All right, that's cool. I like that level of specificity. Okay, what else do I want to play with here before we get too far ahead of ourselves? Oh no, that'll do. Okay, so next off, yeah, okay, that'll be acceptable for currency. Now let's look at the formatting of the other one. So we'll start off with just the formatting, and we won't give it any style or anything like that. We'll just roll it like that, no options. And we can see there that we've got our separation in place. All very good. Now let's see what other options we have available to us. So we have styles, decimal for plain number formatting, currency for percent formatting, and the default is decimal. But it doesn't look like it's forcing the decimal display. Yeah, that's interesting. Significant digits. Number of fraction digits to use. Okay, so here's where it gets interesting, right? I want to play with some decimal numbers and then see whether we can do things potentially a bit more interesting than this, right? So here, double zero. How silly of me is. Of course it's going to round it. Okay, so you can see here that it provided our decimal place there. Now, this is all very well and good, but what if we wanted to do things like, we could just use the formatting and then that's, call it a day and that's done, right? But I mean, there's plenty of cases where you end up going, all right, I want to only show the thousands. So like, you do, 1K, 1,000, 20k, 20,000. Can we do something like that with this system? Perhaps let's have a look at how these maximum significant digits or minimum significant digits, minimum integer digits, maximum fraction digits. I wonder if we can use any of these to do that kind of definition where we group it down in some sort of way. Do we have any examples? Looks like not. So this is where our platform layer could potentially do a bit more. And like this, I mean, like that kind of reduction in specificity is potentially beyond the scope of the International Library. So what I think I will do, instead of wondering what we can, can't, and all that sort of thing, we'll have a play with international format just in here and see what kind of things we can get done with it. So if we take the number format, and let's go ENAU. And let's have a play with this. Like, let's see what minimum integer digits does. Yep. Got format, and that's good. What about this? All right, so you can see that we have some degree of zero padding available to us. All right. And I would say minimum fraction digits is pretty much the same deal. Except it's our decimal side padding. We've got our maximum fraction digits. What does that do for us? Well, that would probably remove any rounding if we wanted to. So let's just have a look at that. Oh, wait, maximum fraction digits is 5. What if we had it as 0? Yeah, you can see there it did a round. Let's see if it rounds up as well. Yes, it does. So that's a rounding. It doesn't floor it, which it doesn't round down by default. It rounds up to the nearest, which is good. I'm happy with that as a predictable way to work. Let's see, what else have we got here? So minimum significant digits. So I reckon this is one that's going to encroach on, yeah, okay, here we go. So you can see here, it means that there must be at least 5 digits in whatever's there. It is allowed to go over. This gets interesting, however. What about maximum significant digits? So here, you can see that once it gets past the first 5 digits, it actually just rounds, which is an interesting one. Yeah. And we could do that. We could go to 1 significant digit and it would round down to 10,000. And I have a bet that if we were to put this up to 5, 1.5, that this would round up, which it does. Okay. So that's what significant digits is all about, is rounding up, rounding down, which is interesting. All right. Now, the unfortunate thing about this is potentially we wouldn't get what's it called? We wouldn't get sort of a localized version of 1,000 grouping for exactly one, like 1K equals 1,000, right? I know that means it for my language, but what would that mean for, say, Arabic or something like that? And honestly, I don't actually know the answer to that question. And maybe that means that we should maybe this is interesting. Maybe what we could do is use format to parts and see what happens. Because if format to parts gives us something that we could work with, so what does format to parts give us? It seems to pull it apart so that we can render it our own way. That's interesting. But yeah, this isn't going to give us abbreviations of numbers. And this will be a platform layer thing for sure, because it's something that, we'll eventually have to drill through various things. But we're not there yet. And I guess this is the thing, is like numbers can be a bit tricky, right? Like when you format numbers in all sorts of different ways, you can format the numbers, but then you've also got the tail end, which could be translated in a bunch of different ways. And potentially what would end up happening is we would have some sort of like that would go through the localization side. Like you'd translate and like units 1,000, units a million, and use that to do your thing. And maybe that's what we'll do. We'll abbreviate numbers in that way. And maybe that'll sort of cross over and deal with that sort of thing. So let's add, I guess, another layer to this, which is so we format number abbreviated. So we have a number, and then what else will we do with it? We would want to say what kind of scale we want to do with it. Or maybe it's one of those ones that automatically tries to bring it down to a certain number of significant digits, right? And then at that point it goes, all right, yep, great, you're in the right spot. So let's think about how that works. And in fact, I'm going to jump into the translation file for that. And then go numbers, units. We have million, we have billion, we have trillion, we have quintillion. We can keep on going. But maybe what we want to do is we want to have large numbers and sort of a standard usage here. Well, this is probably a good place to start, right? And where does 1,000 come from? So we've got a bunch of different prefixes here. We've got gigabytes, megabytes, got all this sort of stuff. What else can we do in finding in the way of symbols? Localizing numeric abbreviations. How about we explore that just a little bit? And like, I'm not necessarily diving into this because this is really critical to our to our software. Like, we'll be able to build it without this, and it'll be fine. That is not useful. Abbreviation 1,000. Which I know, like, I'd use a K. K kilo. Oh, of course. I'm an idiot. Yeah, so K for kilo. So that would work. K kilo, M million, and that's potentially a problem here. So here's a standard for finance, K for thousands, M for millions, B for billions. So you see, it's like, all right, well, we've got to figure out a bunch of different ways in which we handle the abbreviations of numbers. And this sort of maybe comes under the realm of more like formatting unit. As I said, why does K stand for Greek kilo, which means 1,000, so that would do. But in a language of computer science, K is 210 equals 1,024. Okay, great. So you've always got these different things, and depending on whether it's like megabytes or kilobytes or like whether it's computer space or whether it's numbers, like there's a bunch of different abbreviations for them. And likely what we'll have to do, because we're not going to get it from this international library, not that I'm seeing anyway, unless we've got something else under style. Which we don't. You can see that here. We've got percent for percent forming, and the default is decimal. Let's just format percent. Let's just add format percent just because it's there. Just add that to the cast of characters, and then we'll deal with the rest of these cases where we want to have some sort of numeric abbreviation or something like that. And it's actually important to see, how does percent work? Like, do we present percent like this? Let's find out. I'll make that format percentage. I don't like having it format percent. Not a big fan. So now that we've done that, let's just see what comes up with our format percentage there. This is undefined. Oh, I've got to bind it, of course. All right, so you can see there that if I provide 0.2 or whatever, then we get ourselves, that is actually 20%, right? So if we were to provide 20 like this, and we don't need that currency at the end. All right. So if we provide it like this, then you can see that's actually 2,000%. And this would be 200%. Very good. Okay. So it essentially allows you to do things like, say, divide, say, number by a number. That should be definitely 100%, right? And then allows you to do things like, all right, what about 500 by 1,000? Oopsie daisy. 500 by 1,000. 500 divided by 1,000 should be equal to 50%, which it is, right? So it allows you to do that directly without having to do any conversions in between. So yeah, it's kind of nice. It's pretty handy. All right, now, if we're going to think about how this works on the whole, I think we'd have to address the elephant in the room, which is largely that if you want to abbreviate currency, you're going to want to do it here, right? You're going to either want the format there, or you want to maybe, like, you know, crunch it down and then abbreviate the rest. But I'm interested is like how say, let's go Japanese yen abbreviated thousands. And I might not find anything here, but let's see if we can break some of our expectations here. And this works for me, actually. Let's see if there is a standard way to abbreviate lengthy currencies. And this unfortunately doesn't go far enough, so maybe we could find some way. Yeah. Okay. We don't have something on hand, unfortunately, but that's all right. We'd have to hit that. We'd have to approach that problem the moment we sort of did this. So maybe rather than worrying too much about all the other languages, let's just say that this gateway will allow us to do this, and then we figure out some rules around it. So let's say that we had format string and it defaulted to full, right? Well, if we did that, then potentially we could then use that as grounds for abbreviation, an abbreviation type, right? So it's like if format equals full, then we just do this. Otherwise, we're going to take the additional steps to abbreviate this down to some sort of unit. And I think there's a couple of ways you can go here, because say you had a bunch of numbers side by side, right? And all of them were in the same range. Yeah, so we have this currency here, and this one here. And you know, like, they're not going to change much, right? So you'd be excused by like abbreviating them all the same way. But what if you had this outlier? Would you want to display it in the same format as this one, or would you want to display it in the same format as all of the things that are near it? That's sort of a question, and it depends on like your controls. So like, you might want auto formatting in some places, and you might want to force formatting in other places where you say very specifically, I want to abbreviate to this step, this particular step. But maybe it would be better just to demonstrate what I mean by this. So let's say that we're actually going to use this. So we're going to abbreviate auto, which essentially means we're going to abbreviate, and it's just going to pick a particular magnitude to stop at, and then go from there. So what we might do is, since full is pretty much going to be the default, we'll go the other way around and go, all right, if abbrev auto, we're going to do something different. And that something different is meaning we're going to have to work our way down to some sort of lowest significance. And what we could do is we could make some sort of stepper, which will equal the number. And what we're going to do is we're going to keep on stepping down until we get like every 1,000. And then once, every unit of 1,000 we divide it by. And then eventually that will result in, okay, this is the one with the right amount of digits left over. I mean, this is still hard, right? Because are we going to assume that every time we want to pull it down by 3 steps, or like what are the rules here? But let's just say that we're just going to make this stupid, do a simple case to start off with, and then just take it down to its full conclusion, and then we'll see what happens from there. So if we wanted to step this in a Western way, and we are going to just focus on a Western way for now, and if we had to update this code for other languages, then we could. But from a Western perspective, we're always going to be doing it in steps of 1,000. So we've got 1,000, 1K, we've got a million, so million, or 1M, we've got a billion, and then if we have a look at all those names of large numbers again, we can probably find out the rest. We won't do all of them, but we'll go trillion. Let's go to trillion. And then what do we got? Quadrillion or peta. So it's referred to as quadrillion, but it's also 1p, or petabyte, terabyte, billion, was that? Gigabyte? First the SI symbol. What is that? 1,000 million. Oh no. Let's see. So 1,000 billion, 1,000 million, billion, trillion, quadrillion. Okay. So let's say we've got those and we've got some number. We need to work it down and then figure out, okay, so what's left? So we can pretty much count the number of steps that we needed to do to bring this number down. And then we just divide it by 1,000 every single time. And eventually, once the number is under 1,000, then we'll know we have reached a point of significance where we can go, all right, that's done. And now we can render the result. And we can do this with a while loop. I don't think we've ever done a while loop. But essentially what we'll be looking to do is take the stepper and while the stepper is greater than 1,000, we will be working our way down. So while the stepper is greater than 1,000, stepper equals stepper divided by 1,000. And each time we do that, we add 1 to the steps. So if there are no steps, then we know that we don't actually need to shorten or abbreviate the number. And maybe abbreviate is the wrong word. Maybe shorten. Yeah, we'll go for shorten because abbreviation really is something that's more for text with a particular meaning. Like abbreviation and shorted, they're both the same actually. Yeah, let's do abbreviation. Alright, so if we do abbreviation auto and we pull it down, all the steps that we need to, and then once we've got to that level of steps, then we could potentially do some translation. And we'd probably need something in our translation file in order to do that. Something like currency abbreviations. So do something like this. Then we've got million. We'll do big M for that one. We'll do billion. Big B. Trillion. Big T. And then quadrillion, which will be a big P. We can make this a big K, just for now. I mean, because it's localized, we can do whatever we want, really. All right, so we need to map these to these in some sort of easy to understand way. Once we've done that, then pretty much this is pretty straightforward, because what we can do is we can format the number. And then add our translation to it. Now this, again, makes an assumption that like every time we do these, it's always going to be on the end. Again, this is an assumption that I'll wear because we can still fix it in this layer if we absolutely have to. So we're fixing the stepper. And I'm just going to put a K on the end of it just to sort of, before I even do the logic to select, just to make sure that we're actually shortening numbers. So you can see these shortenings here. But then you can also see this shortening here. So that's not cool. We need to figure out what's going on here, hey? And potentially we need to like affect the number of decimal numbers and allow us to control those number of decimal numbers. So at some point I'm probably going to have to just seed to needing some sort of options object here instead. But we'll see. Now, let's see. So with this format stepper, we need to deal with this. We need to make the abbreviation or the suffix to equal something, and that suffix is going to be based on step. And maybe just for now, I could just do a real simple switch statement. And yeah, so if the case is if it's 0, then yeah, I wonder what the best way to do this is. Yeah, I might make this a little function actually, like an immediately invoked function. So our suffix is going to equal this function which we pretty much immediately call. So for example, if we, in this case, we would return this dot translate currency abbreviations dot 1000. Actually, no, we wouldn't do it for that one. We do it for case 1. So for the first one, we actually return a string like that. This is an interesting bit of syntax, but what it essentially means is that we can use return here. So rather than for every one of them being an assignment to suffix, where we do something like let suffix, and then each of these is then suffix equals this, and then break. Instead of doing that, I just want to return inside of it, and it makes it more of an expression in my mind, which is just why I want to do it. If we get to the end, I just sort of want to do this. So if we don't actually deal with the case, then I want to throw that on there. Now we don't actually use this left yet, so let's deal with that. So let's throw the suffix on the end of it. We'll get rid of these. Okay, so you can see we've got 1.3 thousand here, and then we've got these here. Now, let's get rid of those cases by just working our way there. So 2 steps will be 1,000,000. 3 steps will be 1,000,000,000. 4 for 1,000,000,000,000. And finally quadrillion after that. And now you can see the millions here. Now, potentially we wanted to do something like control the number of decimal places. Maybe we're okay with it always by defaulting it to 2, just because it's a currency thing. But maybe we're not okay with it. Like in this case, we specifically want it to be something more like a decimal. Let me see what the international... grouping minimum fraction digits or maximum fraction digits is 1. So if we did that, then that would rein in... Oh, did I make a mistake? Invalid digits value 1. I do not understand. I thought I would be allowed to do that. I guess that's where it gets interesting. Because of the localization, I reckon it's like, no, you can't do that, mate. You gotta have 2 fraction digits. Can I do 0? No, you can't. That's interesting again. Okay, so this might run us into trouble if we ever wanted to show a whole value without the decimal at all. And I think that's probably a limitation of currency in general. You know what? No matter. I don't mind for now. If we get into a position where we do care, then we'll care then. Either way, we've got this automatic abbreviator. You can see that there. But what if we wanted it to be sort of consistent, right? Well, let's see if we can do something like that, where instead we set a particular abbreviation. So that would be something like else if abbreviation if format equals abbreviation K. Let's do abbreviation thousands. That's probably what would make sense, hey? And then we can grab the translation suffix. Start 1,000. And I mean, I'm well aware that this is a little bit messy at this point because we're dealing with all these different cases, but I'm sort of cool with that. So this would be num divided by 1,000, right? And there is obviously a lot of duplication here, right? So we can probably carve some of this out. So let's just have a look at how that looks now. So you can see here we've got the thousands for this one, and thousands for this one, thousands for this one. There is an underlying problem here, which is like with this using this internationalization layer, I can't actually get rid of the digits if I want to be concise there. But as I said, like we're not actually going to be writing an app that does money, so I'm sort of cool with that. We don't necessarily need to go into heaps of complexity here. But I just wanted to deal with this case just to show one particular thing. One thing I do know that we're going to deal with, though, is the formatting of space, storage, format storage. So let's handle that case. And again, we got a number. And we're going to have a format for it, which is essentially abbreviation order. This is one where people just do not bat an eye because of the range of storage sizes and whatnot. So let's have a play with this, right? Jump this, and I'll just bind it before we get there, so we don't run into any issues there. Oopsie daisy. Okay. So now we've got format storage size. We've got some things working for us. Let's make use of it on this end as well. Now, for those who have ever done this, you'll probably notice like this will look a lot like formatting currency, except for the fact that we don't have any following digits or anything like that, and that'll probably give us a little bit more control about how we do this. So we're going to be formatting storage size, and we're going to do it in such a way that is hopefully going to cover all of our different size requirements, petabytes, terabytes, megabytes, kilobytes, or just plain old bytes. So let's see if we can get all of these in place. And let's just let's work under the assumption that we will always want to boil down to one decimal place. Yeah, let's do that just for now. And like, it would possibly make sense at like kilobytes and bytes to never do that. I mean, bytes definitely. Bytes you would never have decimal places, but like for kilobytes and then all the way up, like kilobytes you probably don't care about the bytes inside of it, but yeah, we'll do one decimal place as standard unless there is absolutely no steps. And let's get into it. Right. So the default is going to be abbrev auto. Else it's going to be full. If it's full, then we're essentially just going to return the number formatted. And then we're going to put a space in there. Like, even that's possibly not super localization friendly. But we'll do it anyway, just for now, and we'll deal with it properly down the track once we start to get into the domain of new languages. Even just having this layer here is better than launching in headlong, right? Okay, so and this is possibly where our if we play with our naming here, possibly we're doing the wrong thing, right? Maybe it should be more like storage size units, and then we have abbreviation bytes, which is like bytes, and then we have full, which is same deal again, except we have the full thing. So it'll be something like we have bytes in there, and that actually shows bytes, whereas for this one here, it would just show the B. Yeah. And then as we start to get bigger, KB, I might be getting some of these wrong. I don't know. I don't really care too much, to be perfectly honest, because the whole point of this system is I can fix it in an easy place. All right, so let's carry on here and finish off our stepper. So we're going to be following the same approach for a stepper that we did here, where instead of the units being based on thousandths, we're going to be basing them on 1024. Let me just, there are some things that do weird sort of stuff with that. Just going to make sure I get my numbers right. I mean, 1024 is probably the right one, right? But it pays to just double check yourself before you're ever launching into things. All right, storage size units. Because here, this is the thing. We've got kilobytes, bytes, and these are based on thousands, but there is the other side of things. That has nothing to do with what I'm doing. Computer storage size units. Because here's a challenger that says, hey, no, this is 1024 bytes equals 1 kilobyte. 1024 kilobytes equals 1 megabyte, right? This is what it is. Let's go to Wikipedia, hey? The true home for pedants. All right. So the binary meaning is this one here. So if you use the SI meaning or the metric meaning, then it's low. The binary meaning is 1024. We're going to use the binary meaning for this one because we're on a computer. All right. So we're stepping. Same steps. Only this time the steps are in units of 1024. And I well know that we could simplify this potentially, but I don't want to yet. And when we format this, we are going to format with 1 decimal place as a rule. Except in the case where maximum fraction digits, I believe it is. Except in the case where steps equals 0. In that case, the maximum fractions digits is 0. So we're going to go fraction digits is 1. Rather, if steps equals 0, then it's going to be 0, else it will be 1. All right. And now we should be able to go storage size units dot abbreviation dot kilobytes, and get rid of the rest for now, because we realize we've got ourselves a little option point, right? So we've got our sizes. We've got B, 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 B. Okay, keeps on going, and then it freaks out a bit. So something's going wrong here. And this might be an argument for it's about time to write some tests or something like that, but we'll see how we go first. Might get rid of that space just for now as well. Oh, well, actually, we've got a clear problem right there, don't we? That should be better. So we should at least see kilobytes somewhere. We do. We've got 12, and that suffix does not exist. We need to actually provide that suffix. Okay. And we can keep on going. Megabytes. Gigabytes. Terabytes, I believe, is the next one. Let me double check. Giga, tera, and peta. And we'll stop at peta. Although the likelihood of us ever getting to that level of storage size in the context of the app is very minimal. Right, so we're going to end up with some translations here that aren't actually covered. And that's fine, we'll deal with them. Everyone cruising, everyone happy. This is not not exactly great fun at this point. You just work through it gradually, do your thing, and then you end up with a finished product. Okay, what do we need next? Terabytes. I missed megabytes as well. I noticed a typo that I made over on the other side as well. So let's petatypes. That's not right. Petabytes is what we're after. And then we truck this all over onto this side. Get rid of this because that's not right. And then we've got some units. And hopefully GB shows up as we expect it to. But it does not actually drop it down because we're still using number. So we need to make sure that we're using the stepper, which is the value that's stepping its way down into the value that's needed. So here we go. We've got 1006 kilobytes, which is still under a megabyte. So that's still legit at that point. 9.6 gigabytes, 10.1 kilobytes, 12 bytes. I'm cool with that. All right, but what if we wanted to use the text? We should probably handle that. So here's where our code is starting to get a little long for potentially no good reason. So let's say we wanted to use the full version. And this is where like the difference between abbreviation versus unit, like a reduction of the unit, is slightly different. And that's where I think maybe instead of using the word auto, we use the word reduce, and then we use the word full instead. Yeah, maybe that's better. So, so here we're essentially going for abbreviation and a reduction. And we've also got the other one where we go format, abbreviation, or format equals full reduce. So if it was full, so yeah, this is what sort of determines whether we return the abbreviation or not, right? So maybe we'll just do a really quick function here. Name, yeah, that's what we got. So get size unit string, and then it's like if if format dot index of. So what we'll do is we'll just check this, and I mean this might not work out down the track, but I think it's close enough. So if format or index of abbreviation equals 0, then that means we know it's the abbreviation one. If that's the case, then we would return and we've actually got a this won't actually be well behaved, so we need to do an arrow function instead. Abbreviation dot plus unit. Otherwise, we'll do the same thing, except this time it's going to be the full. And then we can change all of these functions to be get size, or it's more like get unit. I wonder if there's a macro that I could do with this one. Yeah, I could do a macro. Okay, so then dot get unit. Okay. There we go. Nice. And in fact, what we can do, I can shorten this because it doesn't really need to have each with its own line. Like I don't see a need for that in this case because it's going to be just much terser. We're just going to condense it down and make it easier to read if we break it out like this. We could potentially go through all of these steps for currency, but since I know for a fact that I'm not going to do much with currency when we actually build the app, I'm sort of okay with it looking like this. And what we might do is we'll investigate writing a proper test suite for these platform layers as our sort of next port of call, just so that we're doing things right. Now, if it's full, we need that spacer in there. And maybe that that is actually the grounds of the it may very well be the space of the translation file, because there might be some languages that don't want that space in there, and maybe that's the best way to deal with it. Because yeah, it's work, but it's not really that hard to find where these things need to happen. Okay, so that gives us a fairly solid sort of way to represent a large number of numbers. It's a pretty unwieldy way to look at it. Formatting numbers, storage sizes, currencies, and percentages. And like, sure, there are some things that could be improved in this, but I think what we'll do is we'll aim to get some sort of test suite hanging out for all of these bits and pieces, because we're still pretty early in the piece, and I don't want to rush into building the application if we don't have all the pieces in place. But what we might do, we spent an hour. I didn't think we'd spend an hour, but obviously if I go full pedant, I can end up spending an hour doing all this sort of stuff. If there's any questions, please feel free to fire them at me. But what I'm going to do right now is just take a look at where we are, take stock of what we're doing. We have a translation function. We have dates and times, and we have numeric formats. We can't change these on the fly. You have to sort of reload the app with a new language code in place. But I mean, we've got enough for a prototyping layer. We've got a lot of things that we need, right? We don't need too many more things. Maybe we can play with notifications, that's one thing. But what I might do is a bit of a digression into testing. We did a really short one when we were working on some other stuff, but now that we're starting to build up a body of code that we're ostensibly going to rely on, maybe it's time to revisit that so that we can start to work through this, because I think it's worth noting that doing this to test your code is not really the best way to test your code. It's really better if you do actually just use the test to do it. And it's honestly a habit that I probably need to drill into myself a little more often as well. So let's make a date. Next time we're here doing this, that'll be on next Tuesday. I think we'll start working to actually make these stories, make all of these different translation sort of features, especially the ones that depend on us. Like, we barely need to test this, we'd just be testing whether the library works. But when we get into the realm of all of these things, we've got the different rules going on. This is our code, we should test it, right? So that's what we'll do. Let's make ourselves a commit for now, however. Oopsie daisy. And let's see what we changed. Cool. Got some work there. We'll clean up that stuff down the track. All right. So what are we on? Day 17. Add numeric formatters to localize context. And what do we got here? Number, currency, percentage, storage size. All right, we'll tag that with day 17 so we can pick up later. And that's gonna pretty much do it for us today. It's a bit late on my account. It's almost 10:30. Well past my bedtime. I'm getting old. Anyway, that'll do it for me tonight. As usual, if you want to poke apart all of the code that we just committed, all you needed to do is go to github.com/wayoffcider/weekends web app, and you'll find all that code that we just pushed up, and you can go hog wild, play with it yourself. That's going to be it for me. As I said before, I will be back on this on next Tuesday at 8 p.m. Australian Eastern Standard Time. And until then, see ya.